And letting everybody know the session is being recorded. And we're still waiting a few minutes. People are still trying to join, so trying to admit everybody that's coming in. And I'm going to put I just put the link to the Azure guide in the chat once more. Sorry about that. I posted it several times, but people that just came in don't have access to those older chat messages, so I'm reposting. And I will do so once again after everybody that wants to join has joined. People are still coming in. So again, the link to the lab guide is not only on the screen, it is also on chat. You may see it several times. Or if you just joined, you may see it just the last time. I am going to give, yeah, there's still people coming in. So I was going to say I'm going to give ourselves another couple of minutes, and then we'll go ahead and start. For the people that just joined just now, the link that you see on the share screen is also in the chat. I just reposted it. And we'll repost that link in the chat in about 1 minute to give chance to some other people to come in. Okay, let me put that link on the chat once more. And I want to welcome everybody one more time. Let me go ahead and do something real quick. I'm going to stop the share just for 1 second. And let me see, just turn my camera on. I just wanted to say hello to everybody. I want to thank everybody for attending this. We are going to be doing a lot of hands-on and interactive exercises today. I also want to give a lot of time for questions. So please feel free to put questions in the chat as we go along, and we should be able to answer them as we go to make them more relevant. I am going to go ahead and put the link one more time. I think there's a couple of people that are still trying to come in. I'm admitting them right now, but again, I'm going to turn off my camera because I think it's a little bit distracting, but I just wanted to say welcome everybody, and thanks for joining. So let me go ahead and reshare my screen. And let's go ahead and put that link on the chat. Whoops, one more time. Make sure that everybody. So again, the link to the lab guide that you see on the shared screen is also in the chat. So you can go ahead and just click on that chat directly. If anybody has any problems downloading the guide, let me know. but I tested it from multiple accounts and it seemed to be working okay. Technically, you don't need the lab guide to follow along because I'm going to be doing the exercises in the lab guide on screen for everybody to see. And this session is being recorded. So the entire session recording will be available after this. And with that out of the way, I think we stabilized a little bit. So I'm going to go ahead and move to the top of my slide deck. And once more, I want to welcome everybody to our Fast and Furious Azure Bootcamp. This is intended as a hands-on lab for architects, engineers, analysts, and pretty much cloud enthusiasts in general. We have some stragglers. I'm going to go ahead and admit the stragglers, and I'm going to paste the link to, still people coming in. I declare victory too soon. Okay, let me go ahead and paste the link to the lab guide once more for everybody that just came in so they can download the lab guide. You will see the link to the lab guide in the chat. It's in PDF, so feel free to download it. Again, if you cannot or have issues, let me know via chat. But technically, you should be able to follow along even if you don't have a guide, because we will be basically doing everything that the guide says on screen. With that, my name is Gus Coronel. It's right here on the screen. That is my email address. That is my phone. If you have any questions that occur to you after our boot camp, after the technical session, by all means, feel free to reach out to me via email. If you are reaching out to me via phone, I would appreciate a text since I am on the phone a lot. And that way I will know or have an idea of who is trying to reach me and for what. So that would be my only request. If you are trying to reach me via phone, to please text first. Otherwise, email, you can feel free to email me at any time. If I'm awake and have access to my email, I'll gladly reply to any questions that you have. My job as a cloud architect for Checkpoint is to help people understand cloud, play and learn the Microsoft, the Checkpoint and Microsoft solutions available in the cloud. And my job is to facilitate your learning and answer technical questions whenever I can, assist in deployments, help you design environments. That is what architects are here for. There is no added charge for our service. All you have to do is request and find a slot in my calendar, and I'll be glad to help. Today, we're going to be talking about our solutions in Azure, specifically our network security solutions in Azure. Those are the solutions that have to do with inspecting and securing traffic and any attacks that are coming into the cloud through packets, through internet gateways, or through express route connections or VPNs. Anything that is a direct network connectivity or threat is what gets prevented or assisted with the network security solution, which is what we will be talking about today. Just a few points before we start. We are one of Microsoft's top security ISVs worldwide. CloudGuard, which is our solution for infrastructure in Azure, is co-sell prioritized. We have a number of marketplace offerings available in Azure. We are also part of Microsoft Intelligence Security Association, and we were the first security vendor for Azure Stack. So we have a very tight integration with Microsoft. We had for many years, and in many cases, we support new offerings for Microsoft right from the start. One of them being the security as a service with the new Azure Gateway Load Balancer, and I'm going to be talking a little bit about that in the session in a bit. But the point that I'm trying to make is that we work very close with Microsoft day in and day out to make sure that our solutions are fully integrated in their environment. Today, I'm going to spend just a few minutes reviewing our CloudGuard gateway for infrastructure, our network security solution in Microsoft Azure. Then we're going to go into the lab and have a virtual or a feel for what it looks like to deploy systems in Azure. And we're going to learn how to do that by actually deploying and you asking questions as we do. One of the requirements for this session, for the hands-on part, is that everybody have their own access to, or some sort of access to Azure to be able to follow along. If you do not, I am sad to say that we cannot provide a lab environment for the number of participants that we have, but you can still follow along, and the session will be recorded. So even if you don't have access to Azure, you will see all the screens that everybody sees. You will be able to hear the answers to questions people are, of course, asking. So there is a lot of benefit to just seeing the deployments done, even if you don't do them yourself in your environment. But if you do have access to an environment, it's kind of nice to follow along because each environment is unique, and there might be error messages or conditions that may not show for my environment, for example, but may show for yours. So if you are following along, then we'll be able to address those as well. And let's go to the next section. This is just a summary of what our solutions cover in Azure. There are multiple attack surfaces for cloud. Most of what we'll be dealing with today have to do with attacks that come in through the network, but those are only a fraction of the attacks that may impact the cloud. Sorry, can I ask everybody? Okay, or actually, 1 second, maybe that may be me.
Here is a quick guide to navigating this module.
Yep.
There are various controls for playback, including play and pause.
Give me 2 seconds.
Media, next slide, and fast forward.
Okay,
you can.
Let me stop the share for 1 second. Or was that me or somebody else that unmuted?
I believe it was someone else.
Okay, I was wondering if there was a recording that was part of that slide, but I guess not.
I think they just muted.
Excellent. Okay, so let me go back to the slide and just very quickly mention what it's all about. And for those who just joined, and I saw there was a couple of people that just joined, I am going to place the link to the lab guide on the chat once more. So if you go to the chat, you'll be able to see the link to the lab guide we're going to be using today, and you'll be able to download the guide. There are multiple ways that cloud can be attacked, and our solutions are designed to address all those different attack vectors. The hands-on lab today is going to be mainly to address attacks that come in through the network, attacks that come in through the packets, come in through the internet, or come in internally from inside of your own network, maybe from your data center, from a remote site that may be connected to the cloud via VPN, but any attack that comes in through the packets. But I show this slide because this is just one of the solutions that we have. People can take over your identity or steal credentials. There's a lot of API connectivity in the cloud, and those API accounts can be hacked, or those tokens can be used or stolen. So that usurpation of identity is something that we also protect against. There are also going to be attacks or attack vectors that are tied to the control plane. And that is not the network itself, but the portal or the API gateways or anything that has the capability to change your environment, to delete the VNets, delete connections, delete hosts, delete subnets, or block subnets, or change the access via changing the routing or changing the filters in the cloud. So we also have solutions that address the control plane. The hands-on today, again, is going to be mainly around the attacks that come in through the network. But even as we go through this, you're going to see some of the possibilities for somebody else to attack using these other methods, and we'll address those again as they come. Okay, I'd like to show the wheel every time that I'm talking about our solutions, and you may have seen this wheel before, and I'm only going to spend 1 minute here. This is basically the current 5 solutions that Checkpoint has today to prevent the cloud attacks. As I mentioned, we're going to be concentrating today on the network security and threat prevention piece, which deals with attacks that come in through the network. But that's only one of the 5 pillar solutions. We also have posture management that makes sure that your cloud looks and stays the way that you want your cloud to look and stay. It basically goes beyond what normal Azure policies, for example, can do. We will, again, touch a little bit on this sort of like in passing as it affects some of the exercises that we'll do today. But I just wanted everybody to know that we do have the solution in addition to the one we're exploring today. We also have a solution that's specifically for containers and workloads in the cloud. The reason that it's necessary is because you can have dozens, hundreds of workloads, containers, pods inside of hosts, and those are invisible to network inspections or network detection systems because they never leave the host that they're in. It could be an attack spreading inside of a cluster or a pod of containers. So you need a specific security for those. And we have our cloud workload protection for those. APIs is a way that changes get done in the cloud today. Use APIs to create networks, to delete networks, to peer networks together, to allow systems to come in, to change the trust relationship between different accounts and subscriptions. So APIs are usually issued through the network, so they're packet-based. And we developed, or we have a solution that very closely is custom-made to address attacks that come in through the API specifically, including the different API schemas, and make sure that the API requests are not only coming from the proper source and are properly formatted, but also don't contain any malware or injection attacks of any kind. Finally, our last solution for the cloud has to do with intelligence and threat hunting. And this means capturing and enriching logs for all the activity that happens in the cloud. The cloud produces logs, not just for connectivity inside of the network, but also for what people do when they log into the portal. And again, create VNets, create hosts, make changes to the network topology. All that gets added into logs. These logs are literally gigabytes, or in some cases, terabytes per day or per week. Going through the logs is nearly impossible. Our solution system grabs those logs, enriches them with everything we know about the network we're protecting, and then we run analysis. Analysis scans for anomaly detection. Analysis scans for people doing lateral motions or trying to avoid detection. A reconnaissance type of activity inside of the cloud. Data exfiltration attacks. So basically, while the first 4 that I just talked about are about trying to prevent things from happening, the last one is about looking at everything that has already happened or is currently happening and making sure that that is not a threat that may have avoided our first 4 pillars. As I mentioned, we are going to be concentrating today in this top one, the cloud network security and threat prevention. And that is what our lab is going to be about. Before I start the lab, I wanted to touch very briefly as well in the difference between the security that we're going to provide at the network level and the security that Azure provides today. Azure is probably one of the best cloud providers as far as security offerings is concerned. They have a very mature premium firewall that is available and has a lot of specific capabilities built into it. Things like TLS inspection outbound, URL filtering, IPS-IDS, specific application and tagging of Microsoft applications, the ability to do inbound and outbound natting. They do have a nice IP reputation and threat detection database. And I'm going to go ahead and once more put in the chat a link to the lab guide we're going to be using today because some people are still joining. That said, all these security solutions that are available from Microsoft should probably be considered as a starting point for deployments, and they're a fraction of the type of things that you can do once you add CloudGuard into the mix. This is what a network security capability feature list would look like once we overlay or add CloudGuard network solution on top of the basic Azure stuff. The Azure stuff is still there. It can still be used. In some cases, the overlap may be complete between something that we offer, and we usually offer more features or functionality than the Azure counterpart. And that is just because we've been a security leader for over 22 years, while for Azure security is sort of like a bolted on add-on to make sure that everybody has at least some basic capabilities. But what we find out is that multiple customers will deploy us because we have one or two things that they need today that the cloud doesn't give them today. And then by doing that, they get everything else that shows on this list added on top of that. Again, I am going to give everybody a copy of the slide afterwards as a follow-up. So you'll be able to see each and every one of these feature capabilities. This is by no means inclusive. These are just probably the most popular things that we do that Azure is not capable of doing today. But I just wanted to show sort of the overlap because a lot of people saying like, well, I've been using Azure Premium Firewall for a couple of years and I've been very pleased with it. Yes, but there might be some things that you may want to do or some attack vectors that you may want to protect against that are not covered by the Premium Firewall or by the app gateway functionality, for example. Okay, so I'm going to talk really quick about how we normally get deployed in the cloud. And we are not going to do an exercise today that is this complex. This is just to show the multiple ways people connect and to introduce our blueprint. When people deploy in Azure, they're going to be building VNets, they're going to be building hosts, they're going to be building containers. They're going to be placing those in the cloud. They're going to connect their physical networks, whether they are regional offices, data centers, main offices, to the cloud in a number of ways. But normally, this design does not lend itself very well to security and scalability. So what we did is we deployed a blueprint. And what the blueprint tries to do is almost like building a castle around the networks that you're deploying in Azure. And you're going to notice that that castle has two entrances. We have an entrance on the top that is meant to allow the people from the outside, whether those are villagers that want to come into the keep or just the visitors from the outside, they come in through one port, and that port is defended in a very particular way. And then we have sort of like a back entrance for people that are part of the city that's being protected by this fortress. And they also need to access whatever services are inside of the castle, but they may have a different set of checks or detection that gets done in this case. We do not have to have two different doors or two different entry points, but the dual hub or the dual entrance is usually the most popular one. And again, it's done because usually not everybody wants a one-size-fits-all entrance into the cloud for both their internal users and the users on the outside. But this is the concept that we're going to be following today. And it is the concept that we use when we deploy in the cloud. And so a lot of our systems, when we deploy, are going to look a little bit like this. This center core that you see here is basically the regular customer VNets that were created. And then we add a couple of layers. We add an internal protection layer. We add an external protection layer. This would be that top entrance that you saw on the castle. This would be the lower entrance. Your data centers, headquarters, regional offices, MPLS connections, VNet connections, sorry, VPN connections, SD-WAN connections will come in through this inner door, which has a set of checkpoint services to check for it. Anybody coming from the outside will use the door on the top. And this diagram in the top is showing the service chaining capability that Azure just introduced, I want to say about 3 weeks ago. And what that does is it allows any Azure load balancer to service chain any traffic that goes through it through a scale set of checkpoint systems. So basically, what this does is gives the capability to any external load balancer in Microsoft to grab those packets, send them to a checkpoint service for analysis, and returning them back and passing them on. So it sort of converts an external load balancer in Azure into a checkpoint inspection gateway. These gateways that are service chained to the load balancer are fully controlled by the customer. So you get to deploy them, you get to define the rule base that this system has. All we're doing is we're attaching that as a service to your external load balancers, and you can have one of these or you can have many of these. You can have them in one region, you can have them in multiple regions. But by doing this, you can actually control that ingress from the outside into your cloud through that service chaining system. And once it's been inspected, it will be forwarded then to whatever on the inside it has to be. Notice there's another difference between our internal gateway, people that are coming in from our towns and the internal side, and the outside. And that is, in the internal side, we have peerings or connectivity to every single VNet that there is. On the outside, we only have connectivities to the specific VNets that have services or if functionality that wants to be published or made available to the people on the outside. By having the dual hubs, we have, again, the capability to enable different services at the checkpoint level that would be used in here. So, for example, while URL filtering and DLP may be used here to prevent people from the inside of the cloud to connect to sites they shouldn't be connecting, or for data to leave the cloud, this one may be specifically doing AV, malware detection, IPS, IDS, and maybe sandblast, sandboxing, because what we're doing is we're trying to analyze the data that comes from the outside before it goes into our internal network. Now, just because that is the most popular doesn't mean that it's the only design that we have. Some people do not like or care for having two entrances into their system, one for people coming from the outside, one for people coming from the inside. They want everybody to use the same door. In this case, we can also do this. We can build a single security hub. We can have people from the outside hitting that security hub, maybe external partner VNets, again, connecting to that security hub. And we can also have internal connections, SD-WANs, express route, VPNs, MPLS connections, also coming into that system and having a single scale set or inspection point for all of those, and have all the traffic go through those systems before they hit the actual destination. And same whether it comes from the inside or whether it comes from the outside. Logically, there is no real difference between the two solutions. In here, the traffic is intermixed because both traffic from the outside and traffic from the inside is hitting the system. But if your route tables are set correctly, nothing that comes from the outside can hit anything on the inside without hitting this point first. Nothing on the inside can hit anything else on the inside in the cloud without hitting this point first. And the question that I get usually here is, well, when we have something like this, and it's so important to make sure that the next hop route always sends everything to the checkpoint, how do we make sure that that next hop route is not changed? Or somebody says, okay, for this specific traffic, do not send to the checkpoint, but go directly to someplace else inside that we're doing. And that is where posture management, which is the control plane piece, comes into effect. And that is why we do not have just solutions that look at traffic, because not only do we have to take a look at the traffic, we also have to make sure that somebody doesn't change the routing inside. To the people that came in after we started, we are recording the session. We will be making the recording available to everybody. I am also pasting in the chat once more the link to the lab guide we will be using today. So if you go into the chat, you will see a link and you'll be able to download the PDF for the hands-on lab that will be starting in a second. Okay, so to finish, the reason we have multiple solutions, again, instead of just inspecting traffic, is because, again, people can make changes to the infrastructure of the cloud. People can change the architecture. People can change the interfaces on these systems. They can change the routes the traffic is doing. So we want to make sure that nothing changes that, and that those changes cannot be done either from people from the outside that are trying to cause harm, or people from the inside that have some sort of a vendetta against our network. We make sure that we protect that configuration. So by all means, we will be focusing on our network security solution that looks at the packets. But remember, we have that posture management solution as well. And this is a perfect example of why it's important. If you do have commingled traffic on a security hub, you want to make sure that the routing is set very specifically to make sure that every single piece of traffic that comes into this hub touches or goes through the checkpoints before it goes to anything else. Most networks that you deploy in Azure are not going to be like this, but we do have the question as, okay, we saw what you do on a specific region. What if we have what if we're using Azure's virtual WAN solution, which has the capability of connecting to every single VNet worldwide and every single express route through the use of virtual hubs. We are able to deploy a set of regional security scale sets or gateways, and we can have the virtual WAN connect to them. We also have the capability of creating secure virtual hubs using the checkpoint CloudGuard service to secure the traffic that comes through the hubs. So whether you select the managed offering, service offering, which has the checkpoint as the security piece that secures the hub for virtual WAN, or where you have your virtual WAN connecting to a checkpoint VNet for security before that traffic hits anything else in that particular region, and having full control of these. The point is that we have designs for people that are trying to implement checkpoint security in addition to Azure Virtual WAN. All of these designs are possibilities or examples. These designs would, of course, change to adapt to your specific network or circumstances. Again, one of my jobs in Checkpoint is to be available to customers that have questions about what should my network look like if I want to protect it with Checkpoint? How is it that I can set up a checkpoint to protect, to make it the most scalable and cost-effective way? And I continuously work with Microsoft engineers, with value-added reseller engineers, with consultants, or with just customer internal support staff to design these networks or to point out maybe attack vectors on their designs that they have not seen yet. Again, if you would like design services or whiteboarding services or basically just my opinion on a particular design and what to do to improve it, or what would I do different, just reach out. And you have my email and phone number, which I will be given out at the end of the session as well. And you will get a copy of these slides as part of the follow-up, just like you will be getting a copy of the recording. The last point that I want to make is, or very near last, is that our security solutions that we're talking about today are multi-cloud. If you're only in Azure, that's fine. But if you are also in Oracle, or you're also in AWS, or you're also in GCP, the Google Cloud, The solutions that you're seeing today work very similarly to the way they do in Azure. There are going to be some architecture-specific changes based on the differences in architecture, but for the most part, you'll have the same options of creating an internal security hub and an external hub, or a single security for both internal and external. And you can deploy the exact same solution in multiple clouds. You can manage them exactly from the same manager. That manager can be on-prem, and you can push the exact same policies to both your control points in Azure and AWS, and the Cisco ACI and VMware for that matter. So the virtual versions of the inspection points, of the protection gateways that we deploy in Azure and AWS and GCP and VMware and Cisco ASI are basically the exact same software, the exact same OS that runs on our regular physical appliances. So it looks exactly the same way no matter what cloud they're in. They're managed exactly the same way. The feature and functionality is exactly the same. So you can have multiple clouds and multiple environments, public and private, and they are all protected by exactly the same solution with the same central command console and the same central set of security rules, instead of doing Azure security in Azure and AWS security in AWS and NSX security in VMware and so forth and so on. This is a quick example of our lab environment. So we're not going to do anything too fancy today. We're just going to have a single VNet. We're going to create 3 subnets on that VNet. We're going to deploy a single CloudGuard gateway into that VNet. We're also going to deploy a checkpoint management server so we can manage this without having to do any special connections between any managers that you may have in this environment. But the whole point is that just like we deploy a single gateway, we can deploy clusters, we can deploy scale sets, and the steps are going to be very, very similar. As we go through the lab, again, you're welcome to follow along with your environment if you want, or just to see the screens as we deploy. And please ask questions as we go through the labs, because I want to make this as interactive as possible. Again, don't limit yourself and your question to what you're seeing in the lab. If we're deploying something from the marketplace and you have a question that is directly related to the marketplace in Azure or the offerings that we have in there, by all means, feel free to ask the question. You can ask the question via chat. If you feel it's critical, you have the capability to unmute and actually ask the question. But in order to disrupt the demo and the exercises as little as possible, I would ask that you please do it using the chat feature. When we do the lab deployment, you may or may not be able to use the exact same IP CIDR blocks that we're using for the exercise. That is fine. Having a different network CIDR block will not affect the exercise in any way or the capabilities of the system. Normally, if you do have the capability of using the same CIDR block, I encourage it because it basically makes the examples on the guide match your environment a little bit closer. So it's sometimes the answer to your question is a little bit more obvious if you are very closely following the same schematic as the samples. Again, once more, this is the lab guide, and we did have a couple of people join just a couple of minutes ago. So I am going to make sure that I put that on the chat one more time. So if you go into the chat, you will see the link to the lab guide. The lab guide was intended for a different version. So that is one of the little differences that you're going to see between what we do today and what the lab is showing. But we're going to be following the exact same steps. The screens may look a little bit different, which is why I also like to do this live in front of people and sort of have everybody follow along with me. But you'll see that the basic steps are exactly the same regardless. In addition to that, and I'm also going to make this available to everybody, I recorded everything that we're doing. Each one of the exercises in the lab guide, I basically went through those exercises and I made recordings of them. The recordings are on YouTube. These are the links to those recordings. I am actually going to copy this and put this on the chat as well. So even after this session ends, you'll have the capability to look at the recording of each one of the exercises and find out if one of the steps you're doing is not working, whether it matches exactly what the step in the lab did. So let me go ahead and paste this in the chat for everybody. And you should find that in the chat window right now. And with that, that is the last of my slides. And I'm going to go ahead and actually start the lab. And what I'm going to do is I'm actually going to, since I already went through these labs, I'm actually going to go ahead and play the session from the YouTube session. So you have, since I have the capability here to also stop it and answer questions as we go along. The first exercise that we're going to be doing is going to be building our lab environment. Remember, one of the requisites for the hands-on lab was to have your own Azure environment that you can connect to. But since we will be doing this on screen, if you do not have access to the Azure lab, don't worry, you'll get copies of the recording. You'll see what we're doing and all the steps that we're following. So you will be able to follow along as well. If you do have your own environment, it's kind of nice to go through the steps in your environment because there might be things that you see that you would not normally see in somebody else's environment. So, okay, so we're going to be basically creating a VNet, and we're going to be creating 2 subnets inside of that VNet first of the 3 that you saw. If I think I hear somebody, if you have your mic on, please put it on mute. But it is okay for you to unmute it if you're going to ask a question. Okay, so the first exercise, we're going to build a VNet in Azure. We're going to create 2 subnets. If you remember the diagram, we're going to end up with 3 by the end of the exercise, but we're going to start with 2. And hold on a second, I am going to do something here. And that is, I'm going to mute my video because I think I was recording my clicks while I was doing this. Okay, so here we go. And we're going to do play again. And basically, I went to virtual networks. And let me just mention this since I didn't the first time we were here. Your Azure home screen may or may not look like this at all. You can get to all of the Azure services from this screen, whether you have shortcuts visible or not. You can either look at all the services listed, you can search for services. We are going to be first and foremost going to virtual networks. So what I did is on the search bar, I began to type virtual networks. It showed up right up there. So I selected it, and that's how I got into the screen. And from here, I just basically I'm going to do create, and I'm going to create the network. The resource group is not important, so don't worry. You can create a new one. You can put it. You can use a pre-existing one. I am calling the VNet my VNet, just like it is on the example. I'm also using the West US region. You do not have to use the same region. You do not have to call the VNet exactly the same way. I just did it that way because of expediency, basically. If you hit next, you're going to get asked what the CIDR block is going to be. And of course, this is the same CIDR block that we have on the lab. It's a default CIDR block. But if you already have VNets, you probably will not be able to do this, or you can force it, but it's going to tell you that you're overlapping your address space. Again, the CIDR block range doesn't really matter. For the exercise, it has to be big enough for us to create 3 subnets inside of it. Our subnets are going to be /24s. That's why our particular range was 16. The first thing on the subnet side we're going to do is we're going to change the name of that subnet that's created by default. And we can do that by just clicking on that name, which makes us see this piece in here. And I'm just going in here and changing that default name to front end, because front end is the name of the subnet in the lab, and double checking that it is a 24-bit size subnet that is created. And now I'm going to create the backend subnet. I am creating two subnets because I have a public or not protected side and a private or protected side behind it. So we are logically making two entry points into our security gateway, one for traffic coming from the outside. That is, by outside, I mean, that's not secured, and for traffic that is considered to be secure traffic. So we're going to be using two subnets, one for each interface of our system. If we hit next, it's going to go through validation, and then we're going to have a chance to create. And by the way, I'm going to be moving fairly fast at first and slowing down a little bit later. Creating VNets is very basic. So I'm assuming that pretty much everybody here has done it. I'm just trying to make sure that everybody will be able to follow on. So for those that are very new to Azure, I'm making sure that I'm taking a little bit of time here. But don't get too frustrated if you are pretty comfortable with creating VNets. We're going to be moving through all the exercises pretty quickly. And again, what I think is going to be a lot more useful is the capability of asking questions through the exercises. So I'm sorry about my very for all the ads basically in here. Okay, so that was the first exercise. Again, it was very simple, just creating a VNet in Azure and putting a couple of subnets on it. And now we are going to deploy the checkpoint management server. One of the requirements before we started or before we had the registration was that not only you have access to an Azure account, but that you also have or download Smart Console. If you do not have Smart Console already downloaded, that is fine. The console that we asked you to download it was R81, because that is what we're going to be using on our lab exercises today. If you have not downloaded the Smart Console, don't worry too much. There will be a chance to do that in a second. What this exercise number 2 is going to be deploying a checkpoint manager in that Azure VNet that we just created. The reasons whether you may already have a manager, having one just for the exercise allows us to basically create rules or change rules and play with them without impacting your system. So exercise number 2 is going to be deploying that management server. So we are going to go and switch over to Azure. And to deploy the manager, we can use a marketplace ARM template. So we're going to actually type marketplace on the search, or if we have a shortcut to it, we can just basically just click on marketplace. And when the marketplace comes up, we are going to look for either checkpoint or CloudGuard. I just type checkpoint, you can hit return, or you can choose one of these shortcuts here. We want the network security, this one right here, and firewall and threat prevention. We can actually select an ARM template from here, and we're going to be doing security management, but we can also click on it and we'll have that same menu you saw before here. So we're going to be deploying the security management through the ARM template. At this point, I want to add, you do not have to run these templates from the Azure portal. It is possible to download these templates, and you will get the chance to do that before we deploy. So a lot of people sometimes download the ARM templates and modify them before they run them. That is perfectly okay. An ARM template is just that. It's just a set of instructions that do something in Azure for us. You can do the standard, the default template without modification, or you can customize it and download it to add things to it or take things from it as you wish. For this particular item, we are going to use a different resource group. One of the things that I normally get asked is, why do we have to have a different resource group for the checkpoint deployment, for the CloudGuard deployment, than the resource group that we use to create our VNets and subnets? The reason is because we want to keep the checkpoint deployment self-contained. So once you deploy it, we want to have the ability of fully deleting the entire environment without touching anything else. And the easiest way to do that in Azure is basically deleting the resource group. So by limiting the resource group to just the checkpoint deployment, you are able later on to look at the individual pieces of that deployment and delete the whole thing, or move the whole thing as a block later on, maybe from one account to another. Maybe you want to delete it. It allows it to be very easily singled out without touching the rest of our environment. Again, you don't have to use West US. Just make sure that, of course, your region matches the VNet that you created. And sorry about that. Okay, so moving on. You can use public keys, or you can use passwords. The server name that we're using is the same one that is in the lab guide. Again, you can use your own. We allow you to just make up your own password. They have to match. They need to be at least 12 characters, I believe. In this page, when you hit next, you're going to select the version. For this lab, we're using version R81. You do not have to deploy version R81 for this live exercise. You can deploy R81.10. You can deploy R80.40. The more you match the exercise settings, the easier it's going to be to troubleshoot later on if something is not working right. So I strongly recommend that you do deploy 81 for this specific exercise. But if you feel inclined to deploy something else, that's perfectly okay as well. Somebody just mentioned me that there is a typo on the lab guide. If you see any typos, any mistakes on the lab guide, by all means, do submit them to us. You can send them to me. You can send them to your checkpoint team members. It's perfectly okay. It happens, and we want to catch them and make sure that they get fixed for the next version. For license type, we're going to use bring your own license. The reason we're doing this is because the bring your own license has the 15-day eval license with all functionality associated with it. If you use pay-as-you-go here, and you can, you will only have a free sample with the very first pay-as-you-go that you deploy. If you've already deployed a pay-as-you-go checkpoint to play on your subscription, you've already used your free trial. So we normally tell people, if you're doing lab environments, if you're doing testing, if you're doing proof of concepts, always use the bring your own license, because that always has the 15-day free checkpoint license associated with it. That license does not cover compute. So you will get compute charges, but you will not get any license or licensing charges from Checkpoint. And if you have compute credits from Azure, and I believe that we're offering compute credits to most of the people that are joining here, you will be able to deduct those expenses as well. For machine size, I'm going to use the standard machine size that gets selected by default. You do not have to. However, the minimum for checkpoint deployments when you're running the R80 train, whether it's R81, R81.10, et cetera, is a minimum of 2 virtual CPUs. So you do not want to go with less than that. And you really want at least 8 gigs of memory. So you can go a little bit smaller than this if you're deploying on your own environment and you want your compute charges to be a little bit less. But do not try to do a single virtual CPU deployment. And if you are trying to do memory, at least give yourself an instance or a VM that has at least 8 gigs of memory available for the deployment. For installation type, we're going to choose management here. Allowed GUI clients, we're going to make that quad zeros. You can change the GUI client later on. That's just the standard GUI client setting on the checkpoint. We just preset it for you from the template. So you can change that later on. Download and upload from checkpoint is usually licensing and things like signatures for IDS, IPS, signatures for antivirus and anti-malware checks. You do not have to allow uploads or downloads for checkpoint at this stage. You may want to enable them later. It just makes things easier. That way you don't have to download IPS signatures offline and import them separately. You have direct connection or connectivity to the threat cloud, so we can do checks on IP reputation and command and control IPs basically in seconds. If you do not allow this, then that connectivity won't be there. Okay, so the next page, when you click next, is going to be where do you want to put this manager? And we're going to choose my VNet, which is the VNet that we created. And for a management subnet, we're going to use the front end or the public side. We're doing that because our management server is going to have a public IP that we're going to connect to it. When we click on next, you're going to have a validation. You should get a validation passed. If you do not at this stage, it could be because you may not have access rights to deploy items from the marketplace, and you probably would get an error before you get to here, or whether the ARM template is asking for something that you cannot do. A good example is it's going to try to put a public IP address on the management server. If you do not have the capability to assign public IP addresses on your lab environment, then you may not be able to pass validation, or you may have an Azure policy that blocks some of that stuff. So you may have some issues here, but in most cases, since it's pretty basic and since it's a lab environment, you're going to get validation passed at this point. So all you need to do is press the create button at the bottom, and that's going to go ahead and deploy the management server. There's this little notification bell up here where you can see the status of things that are going, but the screen is going to change and it's going to say deployment in progress. I accelerated this piece, so I think this is only going to take about 8 seconds on the screen. I'm going to stop here. It's going to take longer on your lab if you're doing or following those steps in your lab right away or at this point. That is normal. It takes about 8 to 10 minutes to fully deploy a checkpoint manager in Azure.
Good afternoon, everyone.
Good afternoon. Do you have a question or just say hello? Okay, moving on. The reason it takes this long is the actual deployment happens very, very fast. You're probably going to show a running status on your system within 3 minutes of the deployment. But if you connect to the instance and you can actually see the serial console, and we're going to see an example of that in a second when we deploy the gateway, you can see the system booting at first. And after it boots, it's going to create a number of services inside of itself because the manager does have or run a number of processes. So those are the processes that take a little while to start up. So it will take about 8 to 10 minutes to have this fully up and running. And what I recommend at this point is if you have not downloaded the console, the Smart Console for R81, to do it at this time, if you are following along with us. And I'm going to go ahead and show the easiest way to do that is, of course, to go to support.checkpoint.com, type R81 on the search bar, and which I'm going to do. You should be able to do that even if you only have guest access. So you don't really have to have an account of any sort. Just do R81. And when you see the R81 result come back, this is the one that you want. Just checkpoint R81. If you click on that, one of the menu items in here is going to say downloads, which I just clicked on it. And this is what you want to be downloading, the R81 Smart Console. It needs a Windows environment to run. The lab, it mentions that if you do not want to install this on your regular Windows system, you can deploy a Windows virtual host inside of Azure and run Smart Console from there, and then just do an RDP connection into that Windows system in Azure. That is perfectly acceptable as well. If you do want to download it and install it on your system, you can uninstall it after the lab. It's very easy to do. But this is what we're going to be needing to connect to the management server we are currently creating up in the cloud. Oops, and we still have people joining in. Okay, so, and where this was my first one, my second one, this is exercise number 1. So let me go ahead and click on that and click on this. Okay, so that allows me a little bit better view. Okay, so do take that time to do those little extra pieces. And I am going to pause here for about 2 to 3 minutes to give people a chance to, we have about 3 hours set aside, so I don't want to chain everybody for the entirety of those 3 hours. We just hit hour number 1. So I'm going to give everybody a chance to stop for a couple of minutes, stretch their legs, go to, biological services if needed. If there are any questions about what we've done so far, and again, we're just getting started, feel free to go ahead and do those. But also the break will allow us a little bit of time for people to get their Smart Consoles downloaded and installed, and for the management servers to come up. I am, for the people that I saw joining a little late, I am going to go ahead and post the link to the exercises that we're doing right now. Again, so that you can see them or download them or view them at your convenience later on. And I'm also going to paste the link to the lab guide once more, so you can download the lab guide, which is where these exercises we're doing right now are. I do have my own Azure virtual environment, and it's up and you can see it. I have a lot, it's a little bit more complex and has a little bit more items on it than what we're doing for the lab. But the point is, we don't have, if there are questions about things that are similar to the lab or that you need to see examples of, we can do them live as well. And you notice I have a jumper station, which is a Windows station, a virtual station that actually has the console connected on it in here, as well as me having that Smart Console on my regular environment. Smart Console series. So. So welcome back, everybody. We are going to be talking a little bit at this point while the managers are getting deployed, while the Smart Consoles are getting installed. We're going to be talking about upgrades. Today in Azure, specifically, we still cannot do in-place upgrades, but it is coming soon. When I say coming soon, it means that we just released the in-place upgrade capability in AWS, something like 2-3 weeks ago. And Azure is the very next one on the pipeline. I fully expect it to be deployed before the end of the month. So you will be getting the capability of doing upgrades in place in Azure and not having to destroy the VM that you created and replace it with an identical VM with an upgraded image on it. The destroy and redeploy is sort of the the base condition or the way we normally have been doing things for the last couple of years in Azure. That does not include hotfixes though. When you deploy a security gateway, a CloudGuard security gateway in Azure, you can connect to it via the web UI. Just you can connect to any appliance via the web UI, and you can install hotfixes using CPUs. Any publicly released GA hotfix available for Checkpoint physical gateways will install on a Checkpoint CloudGuard VM in Azure. So I would not probably risk it if it is a private hotfix. I would make sure that if you got a special fix from TAC, there was a private hotfix, you may want to ask them, has this been tested in Azure? Because some of our gateways are in Azure and want to apply in Azure. But if it's GA, if it's a GA jumbo, if it's a GA hotfix, it has been QA'd with Azure images before it is made GA. So you can go to, you can connect to an Azure CloudGuard gateway. You can connect to an Azure CloudGuard manager. You can go into the web UI, log in, go to CPUs, and actually install hotfixes just like you can with any other checkpoint system. And again, we will have in-place upgrades via CPUs in Azure. Again, we're expecting them to be released at least in preview before the end of this month. So it's something that people have been expecting for a while and is about to be released. It is not the only way to do upgrades in Azure. My preferred way of making upgrades in Azure, and I think it's even easier than CPUs, by the way, is if you are deploying a scale set, if you're deploying an auto-scaling set of checkpoints, those gateways are made to be automatically configured at creation and automatically deleted during a scale-in event. And it's very, very easy to just create a brand new scale set with a brand new version of the checkpoint system, use the exact same deployment script that the original scale set has, and simply point your load balancer to the new scale set versus the old scale set. You always have the old scale set there, and you can keep it for a day or two. So if anything is wrong with the new scale set, you just point it right back to the old scale set. But if you have auto scaling groups, if you have scale sets, it's very, very easy to just deploy a brand new scale set at the right version and then tell your existing load balancers, your backend scale set is no longer the old version, it's now the new version, and everything works exactly the same way. Since your load balancers do not change, all the traffic routings, all the traffic points are still pointing to the load balancers, and the load balancers is just sending that traffic for inspection or to a brand new upgraded set of CloudGuard gateways. Especially if with a scale set, you have multiple CloudGuard gateways, and it is a lot easier to just deploy an upgraded scale set than it is running CPUs upgrades on each and every scale set member that you have. But that said, in-place upgrades will be available in Azure, hopefully before the end of the month, at least for preview testing. Managers are a little bit more complicated. Managers in the cloud, we still recommend, again, to do the import-export. The in-place upgrades for Azure should include upgrades of managers as well. But one of the things that I normally tell people when they're upgrading managers is always have a copy of the manager in VM. So you can do export-import tests on that VM before you do anything. And an Azure manager is just a VM version of the manager. So you can create a secondary VM manager and do an import to that. You can very easily test by doing a like environment and testing your import into it. But again, in-place upgrades should be ready before the end of the year. Okay, let's see. There's some questions in the chat, so let's see if I have addressed all of them or not. Okay, yes. Some people are asking about the labs, and I think I just answered. One of the things that we asked was for people to have their own Azure environment, especially since we'll be offering credits or compute credits for the environment. We were just not able to, with the amount of registrations that we have, we're not able to create live environments for everybody. Okay, unless there are some additional questions about the upgrades, I am going to go ahead and assume that most management servers have already deployed. And I'm going to basically go on with the exercise. Normally what I do after I create something, I go into virtual machines, I see it listed. I try to see what the status of it is running. And I'm going to see the public IP address that has been assigned to my management server over there. I'm going to copy that address. From here, you won't be able to right click. If you do a right click, I actually did a Control-C. If you do a right click, you're actually going to get a menu there. So that's why you didn't see the right click menu. For my SSH session, I'm using Mobile Xterm. I do it because it allows me to use the private keys in addition to regular passwords. It's very easy in advanced SSH settings to point to a private key in multiple formats. And it also allows me to have multiple sessions open and type the same thing in multiple terminals at the same time. This is not a commercial for Mobile Xterm, but there are some cases where the features make sense for somebody that's working in the cloud. So that's usually what I have it. I'm entering the password, and I'm going to tell it to remember it. For future use. But basically, this is my manager. It's up. The very first thing I'm going to do here, after I connect to it via SSH, or the only thing I'm going to do here, is I'm going to turn CloudGuard on. Now, CloudGuard is a process for the controller that runs inside of the manager. The reason we want it on is because we're going to create cloud data centers at a later time as part of the lab. And that connection will not work if CloudGuard is not activated. There's some internal discussion as to whether CloudGuard should be turned on automatically on every cloud manager. As any process, it takes a little bit of CPU cycles and CPU time. So it was deemed, if people don't need it because they're not going to create data centers, then let's give them the capability of not having it on by default, running all the time, right? But we will be doing some exercises on that, and you'll be seeing what that buys you in a bit. Okay, so you should get CloudGuard IaaS enabled successfully after you do CloudGuard on. This is a brand new manager. There's no reason why you should be getting anything other than that. So I'm starting in my Smart Console. And of course, admin is default. Password is whatever password I defined for it on the Marketplace ARM template when I was deploying it. And the IP that I'm connected to is the public IP for the manager that Azure assigned to us. If all the processes are up, you should get something like this. If you try to connect too soon, it will tell you that it cannot connect. The reason is because the backend processes of the server may have not started up just yet. It's, again, just a matter of waiting a few minutes and trying again, and you should be able to connect. So we're basically, when this is up, we're going to see our management server over there. And I believe that as part of, we may be at the end of the exercise. Yep, we have finished exercise number 2. So I'm going to go ahead and move on to exercise number 3. We do have a question. The links. Okay, so I'm getting asked for the links to the lab guide. I'm going to go ahead and put it in again. And I'm also going to put the link to the YouTube videos we're watching or we're following right now as well. So let me do the lab guide once more. Oops. And I'm going to do the recording links once more as well. So they are not in the chat. Go ahead and let me go ahead and close this and open up exercise number 3. So for exercise number 3, we're going to deploy our CloudGuard gateway. For this exercise, again, it's going to be a single gateway. Deploying a cluster is very, very similar. Again, we're just using ARM templates. So the template just does everything for you. The big difference, of course, when we're deploying a cluster or a scale set versus deploying a single gateway is that you're going to be sending the traffic not directly to the gateway interface. You're going to be sending the traffic to the load balancer in front of the cluster or the scale set. The reason we use, and this is a good time to touch on this, the reason we use load balancers for clusters, for active standby systems, when we don't use load balancers for clusters on regular physical data centers, is because the cloud does not support multicast or broadcast traffic, which is normally what we use to fail over clusters in the real world. So to fail over from one cluster member to another in the cloud, we have a couple of options. One option is to use the API to basically change the routing tables that are pointing to the cluster to point to whatever member is active. And that was our initial way of doing it. However, we found that on very big networks, all pointing to the cluster, people would have multiple route tables pointing to that cluster, and all those route tables had to be updated whenever there was a failover. So we had some customers say, like, it's taking 13 or 14 minutes to fail over. We don't understand why. So we changed the way we do failover, and now we use load balancers. We basically, if the cluster member is active, it's actually answering the health probe of the load balancer. So the load balancer sees the active member as the only serviceable in-service member of a pair, and will send all the traffic to that active member. If there is a cluster failover, the standby will become active, and the primary will stop replying to the health probes. So the load balancer will stop seeing it, and the standby will start answering the health probes. So now the load balancer will see the new standby member as the new active member and will send the traffic to it. That failover happens in less than 3 seconds. So for us, the choice was pretty clear. We can fail over clusters a lot faster if we put a load balancer that is checking for us who is the active member and deciding which of the two systems the traffic should be going to. It also means that we don't have to update our routing tables, because whenever we want to send something to the cluster, we just send it to the internal load balancer. And the internal load balancer never changes. The cluster members may flip back and forth, but the load balancer is always the same. So the routing tables never change. Okay, so that is deploying something other than a single gateway. Again, it's very easy. It's just a matter of going to the marketplace and selecting, again, a cluster member or a scale set in addition to a single gateway, or instead of. So again, we're going to go to the marketplace. We're going to enter Checkpoint or CloudGuard, and we're going to search. Again, we're selecting the CloudGuard network security, and instead of the management, in this case, we're going to select the single gateway. But if you saw that menu, and I'm going to go again, and actually we're going to stop this and go right there and stop it for a second and pause it right there. Okay. High availability is our name for the cluster. That's the active standby. Single gateway is what we're going to be deploying right now. Scale set is basically an auto scaling where high availability is active standby, scale set, everything is active. Multi-domain, we support multiple domain managers up in the cloud. So we deploy a regular security manager, but if you want that to be a multi-domain management server, you can. And the public preview of the CloudGuard Gateway Load Balancer, if you remember at the beginning of the presentation, I mentioned that you now have the capability of making any external load balancer in Azure a service chain to checkpoint. This is what you would need to deploy for that. Basically, it integrates with an existing Azure load balancer. Anything that goes into that Azure load balancer will then be sent to checkpoint for inspection via encapsulation, and then sent back to the load balancer. So it's like the load balancer itself becomes a checkpoint scale set. And you can link multiple load balancers to a single checkpoint scale set. So that's kind of neat. It's in preview mode right now, but the ARM template is available. You can deploy it and play with it if you want. Okay, so we're selecting single gateway. We're gonna hit create. Same thing. We want to set a completely new resource group. We can create it or select an empty one. It has to be empty. If you try to deploy a checkpoint system, a gateway or a cluster or a scale set into a resource group that already has something on it, the ARM template will give you an error. It will say, I cannot deploy into that resource group. It has stuff in it already. This really annoys some people. Again, the reason we want to keep it isolated to its own resource group is because we can very quickly delete or move the entire checkpoint installation without affecting anything else that is on your environment. But if you really need to deploy a checkpoint system inside of a resource group that you already have populated, the answer to can you do it is yes. You just cannot do it using the default script in the marketplace. What I would propose is that you use a PowerShell script to deploy it. You use a Terraform script to deploy it. We have Terraform templates for deploying everything that you saw. Well, maybe not the preview mode, the gateway load balancer, but you can deploy clusters via Terraform. You can deploy single gateways via Terraform. If you make it an orchestrated deployment, instead of using the marketplace standard template, you are able to insert checkpoints inside of resource groups that have something else in there. However, we do not recommend it. It is not a best practice. We would like you to create a brand new resource group every time you make a new checkpoint deployment. That's why we made a new one for the manager, and we're now creating a new one for the gateway. Our region is still US West. That's where we are. For the VM name, I'm going to choose the name that the lab guide has, and I'm going to go ahead and add a password for the system. In here, we're doing R81. Again, you don't have to, but we recommend that you do. Same thing with the sizing. Remember, 2 virtual CPUs and 8 gigs of memory or thereabouts is perfectly okay for a gateway. We do not support 1 virtual CPU gateways or managers in Azure. And bring your own license will give you the 15-day. The installation type, you want gateway only. And a SIG key, I'm typing my standard lab SIG key, which is ABCD 1 2 3 4 5 6 7 8 9. Remember, the SIG key is a one-time throwaway password. Some people have their favorite one. It's fine. You need to know what it is at creation. So the template puts it in there for you, and you can later use it on the manager and make them match. For the next step, again, we're going to choose my VNet because that's where we want our system to be. And we're going to select our front-end subnet as front-end, our back-end subnet as back-end. That's how we call them. It's going to run a validation. Unless you are not able to do something specific because you're not allowed to deploy ARM templates or something like that, you should get a validation pass and you should be able to do create. The gateway is going to be created a little faster than the manager. There's a lot less processes that are running on a gateway. Gateways are usually up and running in about 3 to 4 minutes. I've sort of accelerated the deployment. So your deployment is going to take about 4 minutes instead of something like 12 seconds that it's going to take in this video to happen. But one thing that you can do, and I'm going to show you, is you can actually see the system booting. So you can go to virtual machines. You're going to see the checkpoint gateway there. It probably will say running. It will have a public IP, but you can click on the gateway, just so you could click on the manager. And on that menu, you can scroll. Well, it's showing me where the IPs are. But right now, I'm going to go and take a look at the console, which is what I wanted to show you here. And then I'll tell you why we're looking for this IP. So if you scroll down, there is serial console is there. You can just click on that, and that is a serial connection to the VM. So this is not SSH. This is connecting to the serial port of the VM, and you can actually see the gateway booting up. So you'll see the booting script and output in there as it boots. If it already boot up, you're going to see the login, which is mainly the reason I came here, is to find out what it was already up or not. But remember, it's going to take about 4 minutes. So if you go in a little earlier, this is actually going to be showing you the boot process, and you're going to see all that boot process scroll over. And at the end, you're going to get the regular login prompt once the gateway is fully up and running. The reason I went to networking and looked at this IP is because, if you remember, our manager is in Azure. So our manager could use the public IP to push policy to this checkpoint gateway, but it doesn't have to be. It doesn't have to do that. And we really don't want the manager sending traffic out into the internet and then coming right back into Azure. If both of them actually live inside of Azure already, let me go ahead and make this a little bit minimized. And I'm going to go ahead and show you that diagram again. So for the environment, this is our lab environment. We created the manager, and we put the manager on the front-end subnet. You're going to see that the manager has this address because it's the first free IP address on that subnet. And this manager is going to have this address. This address is what I wanted, because I'm going to tell the manager to push policy to that address, not the public IP that it has, but that private IP that was created for the system. And I was just checking and making sure that 10.0.0.5 is indeed the IP. This IP will be different if your CIDR block is different. It will be different if you deploy the manager on a different subnet. But the manager was given .4, which is the first free IP in that subnet, and this system is getting a .5. Okay, so once I have that IP, I can now switch to my Smart Console, and I can create my gateway object. You may have a menu, not a menu, but a little set of tiles in here that allow you to create a gateway object depending on the resolution of your monitor. Or you can just go to objects and basically say you want to open up a new gateway. And yes, in answer to the question, I am sending a copy of the slides to everybody along with the recording of the session. So we're just creating. You can use the wizard, or you can use the old-fashioned way. We're putting 10.0.0.5. If you remember, that is the private address of the gateway, because we don't want the traffic to go out into the internet and come back in. We're just doing it internally for Azure. We are now selecting the type of appliance, a CloudGuard IaaS. You can also select Open Server here if you want to, but CloudGuard makes a little bit more sense. This is my SIG key, my one-time password. In my case, is that ABCD 1, 2, 3, 4, 5 all the way to 9. And we can hit it next. You should get initialized trust state, and you should be able to get the topology window just like you would when you're trying to import a regular gateway into the manager. If you see here, my ETH0 has a 10.0.0.5, which is the address that I'm going to be using to push a policy into the object. ETH1 is my backend, and it has an address of 10.0.14. If it does not connect It could very well be you have a connectivity problem, but it's very unlikely on the lab scenario because the manager and the gateway are in the same subnet in this case. However, it is possible that if your network's a little bit more complicated, if your manager is on-prem, if your manager is on a different subscription, if your manager is on a peered VNet and not in the exact same VNet, and you're trying to connect to the checkpoint internally, the gateway to make the SIG, and it's not happening, normally what I do is if my SIG fails, I go to my manager, I open an SSH session, and I try to SSH from the manager into the gateway. That usually tells me if it's a routing issue or not. If I can SSH from the manager to the gateway, I know I have routing set correctly. I know that I have connectivity. So there might be some other block in there. The most obvious suspect is a network security group or filter that is blocking the SIG port, the SIG TCP port. When we deploy using ARM templates, we normally deploy using our own network security group, or do not put a network security group on a firewall. It's a firewall after all, so we usually keep it unblocked. That is not always the case when you deploy on a pre-existing network. There might be, it might be impossible to create an unblocked NSG or network security group. You might be using a network security group that was pre-created, and that security group may not allow the SIG transport protocol. So basically, I check routing and I check to make sure that there's no NSGs stopping that SIG from happening. That's the most obvious ways to troubleshoot that. So I'm going to go ahead and finish because I did connect and it showed me and I accepted the topology. So I got my gateway and I'm going to go ahead and for this particular purpose, I did not enable anything but the firewall. I just wanted to make sure that everything was set to basics, and I'm going to create a policy to push into the system now. The lab guide just pretty much says grab the default cleanup rule and just change the drop to accept. If this is an isolated environment, there's no problem with that. You do not have to make it this permissive. An easy way to do this is to create a rule that allows anything on the CIDR block of the VNet, 10.00/16, and give that full access, and then make perhaps a second rule that allows access from your on-prem admin workstations, whichever you're running Smart Console from. But since this is a lab environment, I just did the same thing, and I just did an any except, and I'm going to push that to my gateway in order to do the test. For the people that just joined, and I don't know if they are rejoining or coming back, or whether they're just missed the first part, I am going to repost the links to what we're seeing right now, and the link to the lab guide. I'm going to do that the moment that this finishes. We're just pushing policy. Again, it takes about the same time normally as anything else does. By the way, I believe pushing policy on RD110 is quite a bit faster. Okay, so we're able to push policy. The policy went to 10.0.0.5, which is the IP we gave to the object, and that's where we wanted the policy to go to. If we switch over to logs and monitor, I closed that new tab, which is empty. I just went to the logs tab, and I switched this from 7 days to the last hour. And I just waited a few seconds, and then we're going to start seeing traffic fairly fast. We see traffic fairly fast because the gateway itself is going to try to connect to ThreatCloud. So we're going to see the gateway reaching out and connecting to ThreatCloud for licensing, for DNS, for things like that. So that's a lot of what we're seeing right now. That's our gateway connecting. Also, you're going to be seeing outside traffic in the gateway. It takes less than a minute, usually, for a gateway to be discovered on on Azure, and people start slamming it. The reason is because the Azure public IPs, the public IP blocks are publicly available. Everybody knows what IP blocks Azure uses to give out public IP to their users. And they have robots in continuous scanning for those IPs. And the moment they see something, they hit it on multiple ports. They hit it on SSH. They hit it on TLS ports. They hit it on high ports. And they're looking for known vulnerabilities on web servers that you might be deploying, Windows VMs that you might be deploying. Again, if you're deploying a manager, which uses Gaia, which is, of course, hardened, or a gateway, which uses Gaia and is hardened, they won't be able to do much by hitting the system, even if you have an allow all, because all they're doing is hitting the checkpoint gateway itself. That system is pretty locked down, even if you're accepting packets. I mean, they can try to log in into the SSH. They usually won't be able to. They will try to log in into the web UI. They won't be able to do it. We pretty much have all ports closed except at the Smart Console ports. But just because we did any accept policy and we're seeing traffic hitting that gateway and hitting the manager right from the 45th second or however long it took for them to find it, it doesn't mean that your system is in danger. There's really no sort of routing mapped from the gateway to anything inside of our cloud yet. Okay, let's go ahead and go to the next link. And we're now on exercise number 4. And I'm going to go ahead and open that hyperlink and maximize it. Okay, so exercise number 4 is we're going to build a web server on our Azure environment, and we're going to put it behind our firewall so we can hit it from the outside and we can see the traffic go through the checkpoint on the way in. This shows us basically how that looks when going through the checkpoint and how to set up that redirect so that we can make it happen. So in order to do this, we are going to go and basically create a subnet for a web server. Right now, we just have the front end, the back end. So we're going to create a new subnet. We're going to call it web. We are going to use 10.0.2.0. Again, it doesn't have to match. It's nice. You can leave everything else as default. But that's going to be a purely internal subnet. So the subnet we're going to, the server we're going to deploy there will have no connectivity to the internet whatsoever, except by going through the checkpoint. And we're going to assure ourselves of that by creating a brand new route table for that subnet and making sure that it's only pointing to one place and one place only. And that is the checkpoint system that we have. In here, you can, I use the same resource group that I use for the VNet. Again, it doesn't matter. This is not a checkpoint system, so you can put it on any resource group that you want. And the only reason I call it my VNet routes is because that's what the lab gave it. I'm going to stop here, and I'm going to talk about Propagate gateway routes. Azure automatically propagates routing information using BGP whenever you connect what they call a gateway into Azure. What they call a gateway is a VPN gateway, an Azure VPN gateway. What they call a gateway is an express route connection into Azure that is also considered a gateway. When you connect into Azure via an Azure VPN or an express route, you have the capability of advertising and accepting routes into Azure from that link. So you can say, propagate via BGP, these my data center routes or my on-prem routes, and I, by extension, want to also learn the Azure routes and have those be propagated to my environment. This gets controlled here. You do not have to have this subnet know about your networks being propagated via BGP, via VPN, or via express route. You may want to hide this subnet from your data center networks. You may want to hide the data center networks from the subnet. So you can do that by saying do not propagate. In this particular case, we do not have an express route. We do not have a VPN. I'm leaving propagate gateways as yes, because it has no impact in here. Again, that's nothing. That's a big issue. Okay, it's running final validation, and I'm going to go ahead and hit create. And we're going to see deployment in progress. This is a route table, so this is really going to take less than 5 seconds to come up. So it's not a biggie, and I'm going to go ahead and list it, and it's going to show up in a second. If it doesn't, I'll just refresh until it does. And this is an empty route table. So I'm going to go into my route table, and I am going to add routes to it. I'm going to add 3 routes. That's what the lab asked me to do. One route is going to be for intra-VNet traffic. And by that, I mean anything that is part of this VNet. And I'm going to start with, I'm going to put the VNet there. I want to declare it 10.0.0/16. I want to make the next hop address the internal interface of my checkpoint system. So that's what I'm going to go ahead and pick up, because I forgot what it was. So I'm going to go back. I'm going to go into my virtual machines. I'm going to go into my gateway, and I'm going to look at my networking, and I'm going to look at ETH1, which is my internal interface. And I'm going to see what my IP is, 10.0.1.4, which matches what the lab says it probably would be. And I'm going to put as my next hop address. And all this is saying is that anything that leaves, anything on this subnet that wants to leave for this, anything on this address prefix is going to be sent to the checkpoint. I'm going to do the same thing for the internet. So by default, gateway for this subnet is also going to be the checkpoints. So I'm putting the exact same IP address, and it's going to show it there as the next hop in about a second. And it happens pretty fast because it's just a route update. It can take up to 30 seconds, but it's usually fairly fast. And the final one, I'm going to be doing a microsegmentation route, which means anything inside of the web subnet. And if you remember, the web subnet is 10.0.20/24. Also has to go through the checkpoint gateway. So if I'm talking from one host in this subnet to another host in this same subnet, I'm also going to send this traffic to the checkpoint in order to be inspected. We do that to show that we can do microsegmentation, but it's akin to microsegmentation. If we're going from one host to another host, even if that other host is in the exact same subnet as the first host, we can still force it to go through a checkpoint that is in a different part of that VNet or a different subnet for inspection before it hits that other system. So those are the 3 routes that we have. I'm going to associate that route table now with the web subnet, which is what I'm going to do in about a second. So once that subnet gets created, it's going to show up here, and there we go. There it is. So we have our 3 subnets. So this route table is ready to be attached, and I'm going to attach it to my web subnet. And I do that by clicking on subnets, say associate, and I'm going to go ahead and say associated with the web subnet in my VNet network. Say okay. So now anything that is leaving that web subnet is going to be controlled. Those packets are going to be controlled by the routing table that I just created. Okay, so now that we have a subnet, we're going to create a web server for that subnet. We usually, for our examples, use the Bitnami Nginx open source package. You don't have to use this. We use it normally because it has a free software plan. I usually, when I create it, I don't even use the free version of the item. I should, but it's like 4 cents an hour, so it's not a horrible. Sorry, I believe that the name the lab guide tells us to give the server is web. I'm not very creative. Make sure it's on my correct region, so that I find, sorry, that I can find my other subnets and my VNets later on. There it is. And okay, so yeah, this is that's the standard. The $36 a month equates to about 4 cents an hour, basically. But you don't have to use this one. You can click on all sizes, and I think I'm going to do that. And I'm going to choose on a size that's a little bit smaller. And some of these sizes are free. So for the purpose of this exercise, you don't have to use the default. You don't have to use the default size. You can find out which one is the free micro tiny version of this and deploy that instead. I think I'm going to deploy an A series, one CPU, 2 gigs, which is still not free, but again, it's less than 5 cents an hour. What this, for some reason, Nginx asks us to register an email address and a phone number, and that's new. It didn't used to. But you're going to see that in a second. So I'm going to go ahead and enter my password. And for that reason, you don't have to go with Nginx. Again, you can just do an Ubuntu. You can do a Windows and a Windows server and use the Windows server task for it. This is just a generic web server that we're using for the exercise. On networking, we're just selecting where we want to place our web server. We want to place it on the web subnet. It's the one that we created for it. It would be listed under my VNet. We do not want a public IP associated with it. So I believe I should go in there and yep, there we go. None. We want to leave advanced on, and this is basically the Bitnami template, and most Linux web server images will do this. They will create an NSG specific to the system, which only allows SSH and web traffic, HTTP and HTTPS, and blocks everything else. So I normally just leave it as a default, and you can make it a little more or less, powerful later on. And I just left everything else the same. I didn't touch anything else. So I think I'm going to say, I'm going to keep on going. Advanced. Didn't put any tags on it. So I'm going to keep on going. And I'm going to hit validation. And I'm going to go ahead and deploy. So the nice thing about Bitnami, and actually this is true for almost any Linux system, and this is what I was talking about. When you accept the terms for Bitnami, it will ask you for an email and a phone number. It's basically how they get their mailing list information. You don't have to use the Bitnami code. You can choose your own if you don't want to go through this process and give them your name or phone number. For people that want to send me emails, that is my email and phone number. And again, I will be sending it back with the slides to everybody at the end of the system. And this is what I was saying, the cost for this in compute is about 4 cents an hour. So even if you do not use the free version of the VM, it's not going to hit you that hard. Okay, so by the way, we got about 5 more minutes left on this demo, and then we're gonna do another quick break because we're closing in on the second hour, and then we're gonna basically we just have one exercise left after this. So we're deploying our system. It's gonna deploy again. It's gonna be about 3 minutes or so. It's like deploying a gateway, happens usually fairly fast. I accelerated the video, so that's why it only took seconds here. Now, what we're going to do is, the reason we're coming to the Smart Console is because, if you remember, the web server does not have an IP address to the outside. There is no way for anybody to hit this web server from the internet. We need to go through a public IP. Now, even though the web server doesn't have a public IP, the firewall does. So what we're going to do is we're going to create a rule in our firewall to say anybody that hits the firewall, the CloudGuard public IP on a specific port, we're going to grab and we're going to redirect that to the web server internal that we have right now. So that's what we're going to be doing. I'm coming in here and I'm going to go ahead and I'm going to open the gateway. The very first thing I'm going to do, I believe, is yes, I'm going to disable topology. Now, I do this normally on CloudGuard for Azure deployments. The reason I do it is because Azure has anti-spoofing protection built into its fabric. Spoofing inside of Azure is not possible. The fabric will not allow it. So there's no real reason to do anti-spoofing. You can still do anti-spoofing if you want to force certain networks to come in on certain interfaces, and it's a good idea to do it. But we don't have to worry about that for now. And in most cases, you can simply disable anti-spoofing without any big consequences when you are in Azure. So I am deleting spoofing or disabling spoofing on both interfaces right now. Okay, so with that done, I'm just going to say okay here. And I am going to create rules that allow the specific traffic where you're going to be using for testing. I'm not sure why the lab asks us to create specific rules other than to see them hit a separate rule, because we already have a rule that's allowing everything as part of the system, but we're doing a rule for SSH, and we're also going to be doing a rule for HTTP, so we can actually test one or the other for our web server. So this one's going to be for allow HTTP to the brand new web server that we created. So I want to say, okay, I could leave this source as any. I just put all internet, but we can actually leave that as any. The destination is going to be the public interface of my firewall, of my checkpoint security gateway, because that is the one that has the public IP that we're going to be hitting. So when I create this host, I'm going to call it the ETH0 interface of my CP, my checkpoint gateway, and that IP address is the public IP address associated with ETH0 on my gateway, which is 13.86. Oops, sorry, no. The public IP is you could put the public IP in here, but this is a good thing that I see on the lab. It is better to put in the private IP because the checkpoint gateway doesn't really see the public IP. The public IP, the NAT conversion is being done by Azure. So even though there's a public IP associated with the gateway, the checkpoint system itself doesn't see it. But anything that hits the public IP will be hitting ETH0 and will be hitting the private IP address of ETH0, which checkpoint does see. So that's why we're using the private address in here. And it's really the one that we should be using. Just ignore the multiple objects. You can say yes, but whenever we hit the public IP, we're actually hitting that private IP as well. And we're going to say accept, and we are going to say log, and I think we're going to change services to HTTP. And I'm about to remember to do this in a second, and I just did. HTTP. and say plus and done. So now we can go ahead and install this on our system. Oh, we're doing an add policy. Okay, so the first policy that we did is allows traffic to hit that public IP and come into the gateway. But now we're telling the gateway what to do with that traffic. So we're saying if somebody comes from the internet and hits that public IP on our firewall, which we know it's ETH0, and hits it on a specific port, which in this case is going to be HTTPS, which is the port that we have for our web server, or HTTP. We want to reroute that. We want to send it to another destination, not the firewall. We want to send it to our web server internally. So I'm going to create a host for a web server. I'm going to call it web server, I believe. And I'm going to give it the IP address of our web server in Azure. And I think that is 10.02 something, but we're going to check real quick. So we're going to go to web virtual machines, go to networking. That's my internal address. And we're going to put it in here and say, okay. And this is actually a redirection. This is not natting anything. This is saying any piece of traffic from the internet that hits ETH0 on my checkpoint gateway and it's coming over port 80 or HTTP, keep the original IP address, because remember, we don't want a NAT, keep the original, but then redirect the destination to the internal web server. And we make that a static one-to-one mapping. And we leave everything else the same. We don't want to change the port. We don't want to change anything. We just want the HTTP traffic that's hitting the public IP of the gateway to be redirected internally to the web server. So now I can save and publish this, and I can load it up on our security gateway. And now anytime we hit that public IP using the HTTP port, we're going to be redirected to the internal web server. And I think we're going to test that in a second. Since we disable anti-spoofing, you will get this warning. This is not an error. It will not stop the installation from happening. It's just an alert saying like you don't have anti-spoofing turned on, which we know, and which in Azure specifically we don't really need. So I think now I'm gonna basically go to the web and I'm gonna try hitting that port. That's the IP that I need to hit. That's the public IP for ETH0. And hit return. Or not, just checking for a space, no blank space. And boom, this is the web server inside of the web subnet replying to my request, Bitnami Nginx open source. And it looks a little bit different from the screenshot on the lab guide because the version of the server is a little bit different. This was version 1.16 and we had a much newer version, but that is it for exercise number 4. And we're at the top of the second hour. So we're going to have another 3 to 4 minute rest or break. And then we're coming back and maybe answering some questions, if any, and doing the final exercises for this setup. So with that, I'll see you in about 4 or 5 minutes. I'm going to go ahead and pause the recording. And here we go. Okay, so we're back and we're now going to go into exercise number 5. And over the break, and I probably should have recorded the break, we were talking about the fact that the manager has the capability of connecting to Azure and seeing changes in Azure so it can react to them without having a manual operator do those things. The process that does this for scale sets is called the CME, or the Cloud Management Extension. But the capability of the manager to do that connection, we're calling it right now a cloud controller. So what this exercise is enabling the controller in the manager so that it can connect to Azure. Now, this is a little tricky to do on the exercise, and I'm going to explain the tricky parts. We actually have to create an account in Azure for our management server to connect. If we deploy our management server in Azure, usually that account is created for us, but not always. Especially, it could be whoever is deploying the manager is doing or using an account that doesn't have the access rights that to allow that ARM template to do that piece, right? So in 9 out of 10 cases, we're going to manually create an Azure account for a manager to use. And what this exercise is telling us or showing us is how to create that link between the manager and Azure or AWS or whichever cloud we want to connect to. The secret is the manager needs to be able to talk TLS, HTTPS, or web over 443 to the internet. The reason it needs to be able to do this is because that is where Azure lives. Even though we are inside of Azure, the cloud, the Azure API gateways, the Azure login prompt is out on the internet. We actually have to go to login.windows.net and log in order to be able to give API instructions into Azure that are telling us things about the Azure environments we're monitoring. So what we're going to do is we're basically going to create an account, and this exercise is basically showing us how to do that. Okay. So let's see. Okay, the first thing we're going to do is we're going to create a localhost object. That is basically, we're going to call it localhost, and we're going to use the localhost IP, which is by default 127.0.0.1. The reason we're doing this is because we're enabling a blade in our gateway, which is the gateway that we use to propagate, the blade that we use to propagate information about the cloud to our gateways themselves. And that is the identity awareness blade. The reason we use the identity awareness blade is because we're learning about maybe thousands of objects in the cloud, and updating information about thousands of objects on our gateways is very similar to updating changes on an AD environment. An AD environment can have hundreds or thousands of users, tons of domains, a ton of network objects. The checkpoint gateways need to be aware of all these names and objects in order to be able to, when we integrate with Active Directory, in order to be able to allow access or restrict access to them. So we already have a system that knows how to pass information about hundreds or thousands or tens of thousands of objects to our gateways for our gateways to use. And that is our identity awareness. So we're going to be using the same thing. We're going to turn that on. We do not want to connect to an Active Directory. We're going to fool the wizard. We're going to tell it we're going to do terminal services. We're not. We're going to say, I do not wish to configure Active Directory at this time. And we're going to basically just activate it. When we activate, we get this menu here for identity awareness. So, and this is on the gateway, by the way. So I'm going to click on that. And what we want to activate is actually the Identity Web API. So this is what we're going to do. We're going to go ahead and go into settings. And it's going to ask us who can use this, where our localhost gateway can use it. That is why we created a localhost object. All we have to do is just select it. A client secret gets automatically associated with it. That's just for our client gateway to connect internally to itself to get information about all the objects that we're sending it. And we're going to just say, okay. And once we have this enabled, now anything, we're going to uncheck terminal services, which we didn't want in the first place. I'm going to say, okay, yep, I want to keep the changes. And now I'm going to go ahead and push these changes to the gateway. And the reason we're activating this is because we want some way for the manager to be able to pass on or make the gateway aware, hey, you have to allow this object from Azure to access this other object. And the way our gateways learn it, again, is through the identity awareness plane. So it's just pushing the policy. It should be done pretty soon. By the way, yeah, we started enabling blades, and we have a sample license. Don't worry, it just means that the license is not activated, but we still have the 15-day license. So all of this will work for the lab without any problem. Eventually, as you see, it goes to green. Okay, so creating the object. We don't have to be in the policy screen. I just usually go here because we're going to show certain things after we create the data center object, but we're going to create it from here. We're going to click on a field. We're going to say import. We're going to say data center. We're going to say new data center, and we're going to select Microsoft Azure. A data center is what we call a cloud when we connect to it. And if you see here, it's asking, okay, I can go ahead and I can connect to Azure, but I need an application ID. I need a secret key. I need a directory ID, also called a tenant in Azure. So I happen to have an application ID, directory ID, and I just put those in there. By the way, you can freeze this and try to use them. This were just for the lab. I destroyed this. I give a name to the connection. This is my connection to Azure. So I'm calling this the Azure Data Center. After I put the information here, the app registration information, I say test connection. It says connected. That means I have it. I need to publish or install the database. So I'm going to go ahead and do that. And now I have an active data center. So now when I open the data center window, the manager will go out into Azure and will populate this. This is everything we see on the Azure subscription that I'm connected to. And you can see, we can see virtual machines, we can see subnets, we can see network security groups, we can see subscriptions, we can see load balancers, we can see tags, we can see VMs and scale sets. We see all this because we have now an API connection to Azure, and we're querying everything in here. We actually will query every 30 seconds. When you have a manager and you create a data center object, the manager will connect to Azure every 30 seconds and update any object in here to the latest piece of information. So if somebody deletes a virtual machine, within 30 seconds, this virtual machine is going to be gone. If somebody adds 300 web servers, within 30 seconds, 300 web servers are going to show up in here. And now you start to get an idea as to why we use that Active Directory identity awareness engine, because we're dealing with objects that can be thousands or tens of thousands that are changing continuously. And we need to be able to pass on this to the gateway to be able to act on these items. Everything that you see here can be used to create rules and rule bases. So I can have a rule base that says any system that's tagged in a particular way can talk to any system that is tagged a particular way. All load balancers in Azure are able to talk this specific health pro port to all the things that are tagged as a checkpoint gateway, for example. I want to see my virtual machines and I want to create something from my virtual machines. I can select those and make them part of a rule. Notice that when I select a virtual machine, I've actually can see all the IPs associated with that virtual machine. So by just selecting a virtual machine on the data center, I automatically am allowing access to or from the ETH0 IP, the ETH1 IP, and the public IP associated with that particular interface. So this is pretty powerful, and it grabs pretty much all the information that we need for a particular object. If we are talking subnets, if we use subnets on a regular rule manually, we are defining a subnet by the number of IPs and ranges. If I click on subnet here, I only see the actual IPs that belong to that subnet and any public IPs associated with those IPs. So I don't really see the entire subnet range. If a subnet only has 5 items on it, I only see the 5 IPs that are existing on that subnet today. Again, this gets scanned every 30 seconds. So if something gets deleted or added to that subnet, this system will automatically update and see that. What this lets you do is you can now create a rule and say, I want anything that's on this subnet to talk to anything that's on this other subnet. And the rule will actually use the actual active IPs and the IPs only to create that connectivity between the two subnets that you have. What this lets you do is it lets you create logical access groupings instead of physical ones. And that is very powerful. And tagging is my favorite way of doing it. So I can say a tag, anything that is tagged as a database server in Azure, everything that is tagged as a database server in AWS, everything that is tagged as a database server in VMware on my data center is allowed to connect to anything that is tagged as an application server in Google, for example, right? And those tags will automatically populate all the IPs of all the servers that are tagged that way and will automatically allow that connectivity. You add 300 new servers, you don't have to manually add them because you already have a rule that says anything that is tagged as a database server has a SQL connectivity to this or this other thing. So it doesn't matter where those database servers are. It doesn't matter whether they're in subnet A or B or C or D. You can specifically grab every database server by a tag and use that as a source group or a destination group. So now your security groupings are based on logical groups instead of everything in this VNet, everything in this VLAN, everything in this subnet, everything that ends with an IP that's odd or even. You get away from that. You can now just pick and choose groups, logical groups that are based on the way the items are tagged. You can also make very powerful tag combinations when you create these rules. You can use and or statements. And by that I mean, I can say, I want to create a destination or a source with all my Azure database, Azure servers that are tagged as a database server and have a PCI tag of yes, or a GDPR tag of no, or an internet access tag of yes. So then I can create combinations as sources or destinations of multiple tags in multiple subscriptions. So it doesn't matter whether I have 10 different accounts, 10 different subscriptions, and I have database servers that are tagged there. And some of those database servers have access to the internet. Some of those are tagged as PCI compliant or as having personal identifiable information on them or not. I can create a tag rule that says, I want specifically the ones that have this tag and this tag, but not this tag. So again, you can create very powerful logical groupings and you can use those on your access rules. And then you can have orchestrator programs automatically deploy servers and delete servers. As long as they're tagged correctly, they will be enforced, the connections will be enforced correctly. And then the question I get here is like, if I can allow something to connect to the internet or get SQL access based on the tag that I put on it, how can I control what tags are put on which servers and who is doing that? And we go back into our other solution, posture management. That is what makes sure that the cloud is the way that we want and that nobody's doing in the cloud something we don't want. We can get very specific with posture management saying only these servers can be tagged this way. These servers will always, if it's in production and it's in this system and it has PII on it, it has to have a PII tag. And we can have a system that checks on the format of the tag, make sure that the tag was created and added by somebody who has the access right to do so. And once that tag is created, we can tell it can never be changed except during this particular maintenance windows. So we can be very, very strict as to the control of how things are tagged. Again, that's why we have different solutions for different issues. But I wanted to give you an idea of the power of the controller. The controller is just the capability of the manager to connect into the cloud and learn what's happening in the cloud. If we are deploying scale sets, if we're deploying auto-scaling groups, this is how the manager knows that a brand new gateway just showed up and a brand new a scale set is growing from 2 gateways to 4 or 6. And this is what the manager uses to know that those new gateways now exist, and it needs to automatically do SIC and push policy to those gateways based on the template that tells it what to do. Okay, so that I believe is the end of exercise number 5, and it is. So any questions so far about any of the things that we've seen or done? Okay, well, that's wonderful. We have about 20 some minutes left. I was not going to necessarily go into exercise number 6 because exercise number 6 is really just FW monitor and TCP dump and seeing the packets going in and looking at the packets, the connections flowing through the smart console. And if you build the environment as we're going along, you will be able to do that at your convenience, you know, at any point in time. I wanted to have a little bit of time at the end of the session. And again, we have about 20 some minutes to go into things that the lab has not covered that may be of interest. Whether that is the service chaining on the gateway load balancer solution, which is the new solution that just got introduced. Where was it? This one right here. We can talk about this. We can talk about dual hubs. We can talk about the differences again between when to use an HA, when to use a scale set. Why does it take the floating IP as long as it takes, or pretty much any question regarding deployments and architectures in Azure that the group can think of. If we don't have questions, then we cannot think of questions at this point. Again, not a biggie. You guys have my email address and phone, or you will get it because it will be with these slides as part of the distribution. And you can send technical questions to me at any time. I see special circumstances all the time. People that are saying, hey, we're using this particular brand of SD-WAN system, and I want to be able to create BGP connections to a checkpoint cluster that I have in Azure, or I want to find a way to, I have the virtual V1 in Azure, and I want the east-west check through a checkpoint system, but the V1 is making everybody link directly. That is what my job is. So by all means, any one of those questions can be sent to me. How can we create objects with specific tags, but not that or this one? Okay, and what about management HA pros and cons? Those are excellent questions. So I'm going to talk about management HA first, and then we're going to go into my Azure environment that we're going to play with tags a little bit. HA environments are supported in Azure. I can have a primary on-prem, and I can have an HA backup in Azure. I can have a primary in Azure and a backup on-prem. I can have a primary in the East region in Azure and a backup on the West region in Azure. The managers and management HA works exactly the same way because the software that runs in Azure is exactly the same software. And as long as the management servers have the IP of the standby or secondary server, it will be able to sync with it. And you connect to them and you promote them exactly the same way you connect to them and promote any physical manager that you may have. And as I said, you can mix and match. There are some limitations with multi-domain managers in Azure. And the reason is we can create very large multi-domain servers in hardware, but there are some limits in the VMs when you're creating multiple domains. So I don't remember off the top of my head what that limit is, but I think if you're creating a multi-domain manager and you have maybe 5 or 10 domains, it's not a big problem. If you have 200 domains, it may be an issue to deploy a multi-domain manager in Azure, because Azure itself may not be able to support a VM with that many domains in it. And again, remember, we're attaching multiple IPs to each one of those domains, because each one of those domains has its own smart console associated with it. And there's so many IPs that we can connect to a VM in Azure, correct? So there are some limitations specifically with MDSs, but other than that, HA works exactly the same way in Azure as it does in real life. And a number of our customers, a big chunk of them, implement HA in Azure. The last thing I'm going to talk about in Azure and HA, it has to do with the cloud management extension, the process that the manager runs to configure scale sets. If we have HAs, we have to make sure that the CME process, the configuring process, is only running on the active manager, not the standby manager, if we have a single domain manager. If we have a multiple domain manager, and we have multiple managers that are primaries for different domains, it's fine. We can then have the automatic configuration running on all those. But if we only have a single domain manager, active and standby, even though both of them will have the cloud extension, only one of them should be connecting to Azure at a time and provisioning your scale sets. Otherwise, they may try to fight each other. And this is documented. And if somebody has some questions about this, we can talk a little bit. Okay, so tagging. The specific thing that you want to remember about tagging when we create the groups in Azure has to do with the word query. If you're going to do complex tagging, you need to build queries as part of those tags. So what do I mean by that? Let me just say, for example, I have a cluster in Azure, and I'm going to go to tags. Sorry, this cluster is pretty simple. It only has one tag. I think if I put in here, I have some other tags that I can put in here. For example, type DB server or Active Directory server. So now I have a provider tag and I have a type tag. I can put another one. I can put these are checkpoint tags, and you see these usually on load balancers. On scale set groups. The tags tell allows the scale set to tell the manager, hey, this is the name of the manager that's supposed to take care of me. This is how I want anti-spoofing configured, yes or no. This is the management interface. This is what I want to use as my management interface. This is how topology should be configured. So we normally use tags to pass information on to the management server. But when you have more than one tag, or you have names, different names and different types and values, you can now create queries on the management side to take care of these. And sorry, this is a brand new system, so let me see. I may be able to do it with sorry. When I say a brand new system, my laptop died, so there's a brand new image. So I don't have everything in here. Let me see if I can go into demo and show you a query from a data center. It may not let me though, if it's on demo mode. Proceed. And in the meantime, I'm going to go ahead and start this. So if we don't run out of time, we can actually do some work with it. Okay, so oops. Sorry, manager. Oops. Okay. They want to do any changes. CP manager. Overview. Start. So is this starting visible? Yeah. Okay. So I'm starting that manager. The thing is, this is a brand new image, so I might be able to. Yeah. I don't. Let me see if I have access to some sort of a dummy data center object here. While data center objects are very similar to updatable objects, the big difference is updatable objects are usually just XML lists that vendors give out, like AWS. This is all my S3 addresses, or these are all my public address space. That's updatable objects. The data center objects are the live cloud pieces. So let me see if I can go into here and import data centers. I don't have any. Crap. Okay, so what I'm going to do is I am actually going to do a little video on creating tag queries, and I'm going to add a link to that when I mail out the slides and the rest of the information, so you actually can see how we can build one of those complex tag queries and put it as a source or a destination automatically. Any other questions about some of the things that we may have talked about? Okay.